this video, we are going to explore the astounding engineering that makes you see this wonderful world. How more than 2 million different parts work together in perfect sync with your brain. Engineered to focus in nanoseconds, capable of seeing distant objects as far as Andromeda Galaxy, located 2.6 million light years away. Your eyes are truly an extraordinary engineering marvel. This video will make you realize that for you to be able to see is much more complex than curving a bullet through a car and donut then hitting the target. This video will make you appreciate the gift of eyesight, which you would not exchange even for $1 billion. Here you will see the working mechanics and design principle of the eye in a simple 3-stage process, and in a language that won't put you to slumber. At the end, we will answer some of the most frequently asked questions and some insane facts about eyes which for sure you didn't know. Let's begin with the first stage of visual processing, collection of light. The reflected light from your surrounding enters the eye through cornea, the outermost layer of the eye which bends or redirects the light before letting it pass through pupil, which is the dark opening in the center of the eye. The pupil controls the amount of light to let in, just like a camera aperture. Light then passes through the lens, which is designed in a way to change its shape itself, in order to change the focal length so that the light that reaches the retina is focused and crystal clear. Finally, the light passes through a fluid-filled layer called vitreous humor, which bends the light once again before reaching the retina. The retina, located in the back of each eye, contains millions of photoreceptors called rod and cone cells. These cells work just like camera image sensors, whose job is to collect the light for further processing. Here, the designer used the technique to bend the light in order to focus as refraction, utilizing which the light is bent purposefully multiple times to focus perfectly onto the retina. Refraction is the phenomenon which causes the light to bend at a certain angle as it passes through a medium such as air, water, etc. Amount of bending, called refractive index, depends upon the medium through which the light is passing. Knowing the fact that different materials have different refractive index, the designer of the eye uses very specific material and different components of the eye which have different refractive index. This difference in index makes it possible for the light to curve and reach the retina as intended.
Now, the second stage of visual processing: encoding, converting, and delivering of light data. Each of your eyes have millions of rod and cone cells located in the retina. Just like a computer compiler, which converts higher-level human language to a machine language which computer processor can understand, these rod and cone cells convert light into electrical impulses which brain can read and understand. Once converted, these electric pulses are transferred to your brain through an extremely high-speed data bus called optic nerves. The optic nerve is comprised of millions of nerve fibers. You have an optic nerve at the back of each eye that connects directly to your brain.
Now, the third and final stage of visual processing: decoding and interpretation of the light data delivered in the previous stage. The moment we're born, our brain starts collecting, sorting, categorizing information from the surroundings through our eyes, and prepares a database of known objects in the memory. So later, when we see a familiar object, the brain's patterns recognition algorithm searches the database for pre-existing patterns. If there is a match, you recognize the object. Otherwise, the brain instigates you to investigate the object so that it can put it into a pattern for later discovery. This process of recognizing, sorting, categorizing, and retrieving stored data is so fast that we don't even realize that all these are happening in the background in real time. It takes nanoseconds, not milliseconds. Even with such efficiency, it is estimated that 50% of the brain power is used in visual processing. In fact, our brain produces enough electricity to light up a bulb of 23 watt day and night. At any of the above processes, if there is the slightest of inconsistency, such as damaged cornea, dysfunctional iris or damaged lens, underdeveloped retina or optic nerves, faulty rod and cone cells, etc., the light would not be able to reach the retina, and we would go blind. All this process of encoding and decoding, bending and curving of light is so precise and intertwined that it is much more complex than curving a bullet through a donut and a car, then hitting the target precisely every single time. To give you an idea how complex your eyes are, in medical science there is a dedicated department for studying eye-related issues called ophthalmology. It takes 2 to 4 years' time to get this degree. Now let's find out one of the most frequently asked questions on eyes: the pixel count of our eyes. According to scientist and photographer Dr. Roger Clark, the resolution of the human eye is 576 megapixels. That's huge when you compare it to the 48 megapixels of an iPhone camera. The megapixel resolution of your eyes is the wrong question. The eye isn't a camera lens taking snapshots to save in your memory bank. It's more like a detective collecting clues from your surrounding environment, then taking them back to the brain to put the pieces together and form a moving picture. Another frequently asked question: are there really more than 2 million parts in your eyes? There are 7 major components, namely cornea, iris, pupil, vitreous, lens, retina, and optic nerves. Each retina has an estimated 7 million con cells and 1.7 million rod cells. Combine all these, you have more than 2 million dedicated parts for your eyes. Now let's see some interesting facts about your eyes. All babies are colorblind at birth. Blind people can see their dreams if they weren't born blind. Your ears and nose grow throughout life, but eyes stay the same size from birth. Fastest muscle in the body is located in the eye called iris. This muscle expands and dilates the pupil in response to the intensity of light. Color of the iris is actually you call the color of the eye. The world's most common eye color is brown. Some people have 2 different eye colors, a condition called heterochromia. If you think nature's engineering deserves attention like this, give this video a like and subscribe to this channel. Also, let us know in the comment below, what would you like to see next?